Okay, let's go over the quiz. So the first thing you want to do is read the question and put your name. So I put my name as me. Okay, that was a joke. So we have the time it takes to get to the gate, the time it takes to go through the gate, and the distance to the gate. The distance to the gate. So the question is, how do we find the velocity? We're trying to find the acceleration. Yeah, okay. So if I know the time it takes to get to the gate and the width of the gate, then I can say the velocity is the change in distance over the change in time. It went 0.08 meters, and this is the time. So if I take this divided by this, I get this. So 0.08 meters divided by 0.23 seconds, I get 0.35 meters per second. And then I do the same thing for this time, same distance. And you notice the times are getting shorter because it's going faster as it goes down the track. But here I get my velocities, 0.5, 0.62, 0.72. Now, I know that the acceleration is a change in velocity over a change in time. So this looks like the slope equation if I plot velocity versus time. So I'm going to plot velocity right here versus time. Now, I'm not plotting the time, the gate time. I'm plotting the time to the gate. Because imagine I have this. Here's my car, and then here's my gate. I want to know how fast it's going at this time right here. So I'm going to wait until it gets here, record the time, and get the velocity from this time. So I need this velocity in that time. Now, when you're making a graph, right here I have times from 1.14 to 2.3. You definitely want to have your numbers spaced out evenly, but you don't have to start at 0. So I started at 1.1. I know that's weird, but I just did. Oh, yeah, that's fine. And then, but I had enough, I counted the squares, so I'd have enough to get up to 2.3 if I went 1.1, 1.2, 1.3, and so forth. Okay, so when you're doing this, if your data only takes up half the graph, you could always make it twice as big, right? So you can make it go off further. It doesn't have to, but if you make it super tiny, it's going to be hard. And then I did the same thing for the velocity. I started here with 0.3, 0.4, 0.5, and so forth up to 0.7, because my fastest velocity is 3.5. Okay. That's weird. Okay, that doesn't matter. Okay, so I went ahead and did the data points. Actually, is that 0.3? Yeah. That's 0.35. See, there's 0.3, and that's 0.4, so halfway is 0.35. And at the time of 1.10, 1.14. So there's 1.1, 1.2, so it's about halfway in between it, so it's right there. Can you see that point? Yeah. And I had to put the other data points on there. Okay, so there's my 1, 2, 3, 4 data points. Now I want to find the slope, so I'm going to draw a best fit line. So this is my approximate best fit. It's kind of hard to see, but it doesn't have to be perfect. That's probably not the best, but it's good enough. So there, drew my best fit. Now what I'm going to do is find the slope of this line, not the points. So what I like to do is look for things like this. You see right there where it crosses the axis and the grid lines? So it's an easy point to find, and here's another one. You don't want them too close together or the error is too big. So I can get this point and I can get this point. So the acceleration is going to be the change in velocity. So this is 0.6. Sorry, I'm writing 0.6 meters per second minus 0.4, and those are meters per second, over the change in time, which is going to be 2 minus, that's 1.4. So I get an acceleration of, let me put it in my calculator right here, really quickly. I should have had this already done, but I didn't. So I get 0.6 minus 0.4, that's easy. 0.2 divided by, I can do that one too, 0.6. And I get 3.33. 0.33 meters per second squared. This is meters per second. That's seconds. So meters per second divided by second, and there's my answer. The end. And they lived happily ever after.